Let's continue discussing with aggregation. We will talk about group by key, which should be the least preferred one when it comes to aggregating the data. Because if you try to group the data um, in order to aggregate, then using reduce by key or aggregate by key will yield much better performance as per this note. And the reason is combiner, group by key does not use combiner. It just groups the data, and we will see it in action. So that being said, to use group by key in action, let's first create the order items. Um, uh, First read the order items dataset and create RDD out of it, and then we will take it further. So I'm copying this one, which will give us RDD of type string with all lines in order items as elements in that RDD. Okay, so I'm pasting it here also. And you can see okay. And here order items have 6 fields in each of the record. Order item ID, which is primary key, the first element. Second element is order item order ID, which is foreign key to order ID in orders table. Then product ID, quantity. The last one is price. And this one is order item subtotal or revenue for that record, which is nothing but derived field of quantity multiplied by price. Okay. So now the problem statement to demonstrate group by key will be to use this dataset and get revenue for each order ID, and also sort the data for each order ID in descending order by order item subtotal. So we'll try to accomplish two things using group by key. One, get revenue per order ID, which is nothing but second field. Second one, get data in descending order by order item subtotal for each order ID. Okay, so in both the cases, order ID is the key. And now if you look at the description of the group by key, it has to be called on a data set of KV pairs, key value pairs, which has nothing but a tuple with the two elements, or in short, it is also called as paired RDD. So first we have to convert our input data, which is of type string, to paired RDD. Our input data is of type RDD of string, and we have to convert it into paired RDD. The way we can do is by using map API, map of, let me give the name as OI, then OI dot split, comma is the delimiter, and then first element is second element is order ID, so I have to use subscript of 1, and it is of type integer originally, so we have to type cast integers. Similarly, we can get the revenue by subscripting 4, because the fifth element in our dataset is revenue, and then it is of type float, so I have converted into float. Now let us run this. And then order items map dot take of 10 dot for each println. Now if I use group by key, what will happen is, for example, in this case, for this order items map, if you take order ID as 2, there are 3 records. When I use group by key, these 3 records will be converted into something like this: 2 comma 2. I'm sorry. Okay, so it will still be a tuple, but for each order ID, there will be only one record after grouping by key. That's why they call it as group by key. Okay, and then you will see 199.99, 250, and 129.99. This is how data will be represented once we apply the group by key. And let us see that in action. This also I will write outside these problem statements, because both use order ID itself as key. So I will be creating only one variable for both the purposes, which is nothing but order items GBK, which stands for group by key, equal to order items map dot group by key. And group by key doesn't take any parameters, doesn't take any mandatory parameters such as function when it comes to reduce by key or aggregate by key, or map or flat map, they take function. Whereas this group by key does not take any function as argument. So now I copy and paste it here. And if you look at the sample data, you can see for each order ID, it returns a compact buffer. Compact buffer is nothing but a Spark collection. It is under a package called org.apache.spark.util.collection. You can find the compact buffer. It is not showing up here, but yeah, the compact buffer is part of this package. org.apache.spark.util. Yeah, collection dot, and you can see the compact buffer here. Let me see. Yeah, org.apache.spark.util.collection.compact buffer. I don't know why it is not showing up here, but this is the package which contains the compact buffer class, which is nothing but in-memory representation of a collection. But the actual versional type of the collection is nothing but RDD, and in that RDD, each element is of type tuple, and the value which we are seeing, which we have seen it as compact buffer, is represented as the iterable. So compact buffer is nothing but iterable. So with if it is iterable, then we can actually do whatever operation we can perform on any iterable. We can convert into a list and we can perform list operations. We can convert into a set if you just want to eliminate all the duplicates. If the values are of type map or key value pairs, we can actually create a hash map and do map operations. So we can do whatever we want by using this iterable. The knowledge of Scala collections will help you a lot to get the solutions easily. That being said, let us preview the data once again. Not this one, this one. And let us copy this. Okay, and here val L is nothing but iterable of float, and then I am saying iterable of paste those values. Okay, I should not treat it as float. I can actually say something like this. To float, I guess. No, it doesn't work like this. Okay, let me. Let me get the syntax right. I just want to create a collection. Okay, I should not use that data type here. I can just say iterable here, and then it will actually create the result. By default, it will be converted into list. So now we can actually, if you want to typecast it to list, you can set to list. If you want to typecast it to set, you can set to set. If it is set, if there are any duplicates, those duplicates will be eliminated. So like this, you can do whatever operation you want. So in this case, L will be list now. And if you type L dot and hit tab, it will show all the operations. Now, if you want to get the number of elements in it, after grouping by, let's say I want to get the count, just I can say L dot size to get the number of elements. If I say L dot sum, it will give the sum of the elements. You can use all kinds of operations you want. Okay. So to get revenue per order ID after grouping by key, we have to apply transformation because our input records are like this. Okay, and for each of this record, I just want these things to be added and get the sum. Okay, so for that we have to use map. For each input record, we are getting one output record, and the value or the second element in this input record will be aggregated, and we are trying to get the revenue for each order ID. So for that reason, I can say order items gbk dot map. Okay, in this case, rec is of type tuple. Okay, and to get the collection from this tuple, which is second element, I can say rec dot underscore 2, and then it is of type compact buffer or iterable. So if I want to perform any list operation, I can convert into list, and then to get the sum of the sum of all the elements in that list, I just use dot sum to get the revenue for each order ID, and then I'm saying take off 10 dots for each println. This is how you can actually get revenue per order ID. Okay. If you want to get 1 minute, actually, typically I want both order ID and revenue to be printed. So for that, what I can do, I can say rec dot underscore 1 comma, and then I perform the operation on the collection. Now we will get to the tuple. You can see the order ID and the revenue for each order ID. Okay. So now we will demonstrate one more thing using results after group by key, that is to sort the data in the descending order by revenue for each order ID. Okay, so here instead of printing like this, I want to flatten it out and get the data in descending order by these elements. Okay, so to flatten out the collection, always we have to consider using flat map. So all group by key will be either followed by map or flat map. For each input record, if you are getting one output record, you use map. For each input record where the value are now a collection, if you have to flatten out and get multiple records, then you have to use flat map. Okay, so here we can say order items gbk dot flat map. Okay, rec is of type tuple, and here I want to print both rec dot underscore one is nothing but uh, the key, which is nothing but order ID, and the value has to be um, uh, one element at a time in descending order by revenue. So what we have to do is, first I have to get rec dot underscore 2, which is nothing but the collection, change it to list. Okay, and on the list, for example, let's take L itself. We have this list, right? So if I have to sort the data, I can say sorted, and the data will be sorted in ascending order by default. If I want to do it in descending order, okay, let's see if I can actually use, I have to sort by. Okay, sort by takes a function. In this case, let's say O is the parameter name for that function. It is of type float in this case, or double. So just to get it in descending order, I just have to say -O and hit enter. Now you can see you got the data in descending order. So L dot sorted can be used on primitive types where data will be sorted in ascending order in natural order of the data, which is nothing but ascending order. You just say sorted, it will just sorted by natural ascending order of the primitive types. Whereas if you want to use a custom sorting, if you want to perform custom sorting, then you might have to use sort by. Sort by takes a function, and this function will drive the functionality in which data should be sorted. Okay, so here our argument is of type float. By just negating, we can actually get the data in sorted in descending order. So now coming back to this, I can say rec dot underscore dot two, rec dot underscore two will give the collection. Dot to list will convert into a list which have the sort by operation. So I can say sort by here and then use this logic. O implies -O. Once the data is sorted in descending order, I just want to return that along with the order ID so that the data will be both order ID as well as the revenue in descending order. So what I can do here, I can say map. In this case, let's name it as K. K is nothing but the revenue in descending order. Okay. Along with that, I want to get the order ID also. Order ID can be fetched by using rec dot underscore one, comma K. So for each collection, first we are converting into list and then sorting in descending order, and then converting into tuple by tagging order ID with each element after sorting that in descending order, and we are returning that. As we are using flat map, now the each for each order ID data will be displayed as multiple records. Only difference between order items map and order items gbk.flatmap output will be in order items map data will be randomly sorted within each order ID. Here data will be sorted in descending order by revenue. Now I can run this. You can see it is working. So let us assign it to a variable. Well, orders sorted by revenue. orders sorted by revenue dot take of 10 dot for each println. Now you can see for 65,722 data is sorted in descending order by revenue. That is the case with each and every order ID. Data is sorted in descending order by revenue. So this is how you can use group by key, not only for aggregation but also for advanced sorting, uh, and also ranking, etc. And we will touch base group by key once again a bit later to perform ranking as part of the standard transformations. That being said, we have seen how to use group by key for aggregation and also for sorting. When it comes to aggregation, group by key should be given lower priority. It should be only used when the solution cannot be expressed using aggregate by key or reduce by key. Because group by key doesn't use combiner, it can be significantly slower compared to reduce by key or aggregate by key.